This lecture will provide an overview of the correlation coefficient, which is one way that we assess the degree to which two variables are related. So what is the correlation coefficient? The correlation coefficient, also known as Pearson's R, sometimes just written as R, is a statistic that measures the relationship between two variables. So how much do these variables go together, or how much do they covary? So for example, how much is the income of an individual related to the income of their parents? So we're not going to go through and calculate the actual calculation, the formula for the correlation coefficient. There are great Khan Academy videos if you want to check that out a little bit more. Instead, we're just going to think a little bit about the intuition and look at the number that you can have for a correlation coefficient to try to understand what it means. So the coefficient can fall between -1 and +1. So what do these numbers imply? Well, if it is positive, it's more than 0, that means that there's a positive correlation. In other words, as x increases, then y will also increase. If the number is less than 0, so somewhere in the negative range, there is a negative correlation, meaning that as x increases, y will then decrease. And if you find a correlation coefficient of 0, it means that there is no correlation whatsoever, that if you have an increase in x, that it's not going to have any effect on y. So to understand it a little bit more, let's go through a couple of examples. So first, and just before saying that, a note that this is most appropriate when the variables are interval or ratio. So here we have a scatter plot that compares high school GPA and Colby GPA. So logically, it makes sense that they would be related, right? If you studied a lot in high school and you got very good grades there, then you're going to bring those study skills with you to Colby. It's not a perfect relationship. There's some variation. It's not completely on a straight line, but we see that it's quite related. And overall, as the high school GPA goes up, so does Colby GPA, right? So if you were getting a 3.9 in high school, then you're probably going to get something close to that at Colby. And again, I don't actually think that these numbers are going to be quite so tight on this line. I just made this up for the sake of the example. So one way to tell if there is a positive or negative association with this case, we can kind of see just by looking at it that it's sloping upwards, that it's an increase in x is also leading to an increase in y. But in order to think through that a little bit more, what would help is if you look at the means of each of your variables, right? So you look at the mean high school GPA, you look at the mean Colby GPA. So here we have the mean high school GPA is right around 3.5. And so you have that in between scores can be either above the mean or below the mean. And likewise, we did this for Colby GPA. So you have this broken down into 4 quadrants. So if it's positive sloping, you're going to see the correlation, if the correlation coefficient is positive, it's going to be positively sloping, and that means you're going to see more data points, more or less here and here, than you'll see here and here, right? There's only a couple that are in these quadrants. Most of them are going up like that. So here's an example of a negative correlation. So if you are playing a lot of video games, your GPA at Colby is going to be going down. So here we have somebody who's playing video games for 12 hours a week. They're not really having any time to do their studying. Here we have somebody who is not playing any video games, is doing quite well. Just because you're not playing video games doesn't mean that you are getting 100% and everything. So there's some variation along the way here, but overall it's a negative slope. As x increases, y decreases, right? So once again, if we look at those means, we'll see how everything fits into the quadrants. And so here is the mean Colby GPA and the mean hours a week per video game. So, unlike last time where there were hardly any data points in these quadrants, or in the quadrants that didn't fit with it, we see a few more variance here. But overall, we still do see a pattern where most of the data points fall in one of these 2 quadrants, sloping downwards. And you can imagine that there is no correlation between shoe size and Colby GPA. There's no reason to think that there would be a relationship, and in fact in the data we're not seeing one. So it took the mean of Colby GPA and mean shoe size, and if you look at the 4 quadrants, it's all scattered all throughout, right? You can't see a clear trend going in one way or the other. So to visualize what various correlation coefficients look like, I have several of them right here. So a perfect -1 correlation coefficient, this isn't even perfect, but it's going to be one where everything is laying more or less on a straight line, that they are varying completely 100% together, right? And they're very, very tight to that line. Here we have the opposite of a positive correlation, where everything is, again, pretty much on this line, but sloping upwards, right? And this compares, let's go over here, these correlation coefficients of 0, where you have 2 different patterns of the data. This one, everything is all scattered about, and here they're on a line. But the thing is that this line is a horizontal line, right? So this means that the increase in x doesn't do anything to y. Likewise, an increase in x here doesn't do anything to y. And so this is a correlation coefficient of 0. There's no relationship that we see in the data. And then we can often have in-between cases, and you'll basically never see an R of -1 or +1. That just doesn't happen pretty much ever, where it's perfect on that. Instead, you'll get something closer to 0.6 or -0.6 or 0.3, right? So here you see that this is, things are kind of close to the line. They're definitely downward sloping, but there's some spread. Here, it's a positive relationship. It's going up, but it's a lot more spread out. And so we see there that it is a little bit closer to 0 than this one is here, right? There's less of a tight relationship. So when you're interpreting correlation coefficients, the value of the coefficient and not the sign indicates the strength of the relationship, how much they're correlated. So if you have 0, that means there's no relationship. But if it's, 0.2 or less, that's a weak relationship. If it's between 0.2, 0.4, or -0.2, -0.4, it's a weak relationship. Moderate if you're between 0.4 and 0.6, then getting stronger between 0.6, 0.8, and then very strong to the point of basically being impossible to find almost between 0.8 and 1, right? So the sign tells you if it's positive or negative, but the strength of the relationship, how much they're correlated, is based on the size of the value. So how close is it to 1 or to -1?